My dear students, I am going to teach you the second part of lesson first of 12th class. Second part is the most important part. In this part, and I will teach you an equivalence relation. An equivalence relation is one of the most important relation which plays a significant role in is an equivalence relation. It means this relation is very important from mathematics point of view. And one thing I want to tell you, if you want to study this relation, you have to study three relations. One reflexive, second symmetric, and third transitive. If in any relation these three relations are found, listen to me very carefully. Take any relation, and in that relation, if these three relations are found, if these three relations are proved, found means proved. If these three relations are proved in that relation, then that relation will be an equivalence relation. This is the most important topic to understand. Now I am going to tell you some uh, aspect of this relation. First, what is reflexive? If a pair AA belongs to R, for every A belongs to A. Second, symmetric. If A1, A2 belongs to R, then opposite should also belong to R. Understand here. Third point, transitive. If A1, A2 belongs to R and A3, A2, A3 belongs to R, this implies A1, A3 should belong to R. If this pair belongs to R and this pair belongs to R, this pair should also belong to R. It means we have to check these three relations in any relation. If these three relations are proved, then that relation will be an equivalence relation. I am going to make you understand with the help of an example. I am taking an example. A is equal to 1, 2, 3. A is equal to 1, 2, 3. Find out the product A into A. A into A is equal to 1, 1, 1, 2, 1, 3. Now take second 2. 2, 1, 2, 2, and 2, 3. Now take third. 3, 1, 3, 2, and 3, 3. Suppose this is an this is a product of A and R is the relation. R is the relation in this product. You know that R is a subset of any product. R is the relation of any Cartesian product, you can say. Then R is 1, 1, 1, 2, 1, 3, 2, 3, and 2, 1. And 2, This is the relation. I have taken a relation R from this Cartesian product. Now, check all these. Check all these three relations in R. One thing, first, reflexive. In reflexive, A11 should belong to R. This 1 belongs to R. Here, we have to check whether that pair in R is present or not. This is the condition. A11 is the pair is present in R. Hence, this is hence R is reflexive. Second, symmetric A1, A2. From here, see this point. A1, A2 belongs to R. Then the opposite of this should also belong to R. Find out this pair in this 1, 2 belongs to R. And 2, 1, this is 1, 2 and this is 2, 1. Both the pair are present in R. This implies 2, 1 also belong to R. Here you can see 1, 2, 2, 1 and 1, 1. Both this is the first condition. This is the second condition. This is the second condition. Now third condition, transitive. Transitive. In transitive, see here, A1, A2 belongs to R. A2, A3 belongs to R. These two pairs belong to R. If these two pairs belongs to R, then A1, A3 also belong to R. Then this relation will be transitive. Listen to me. A1, A2. It means third 1, 2 belongs to R, and 1, 3 and 2, 3 belongs to R. 2, 3 belongs to R. Both are here. This implies that 1, 3, 1, 2, 2, 3, leave this 2, 1, 3 should belong to R. Whether this 1, 3 is in the relation? Yes. Yeah, this is the 1, 3. 3 lines shows that. One line shows that this relation is reflexive. 2 lines shows that this relation is symmetric. 3 lines shows that this relation is transitive. Hence, the condition of these three, reflexive, symmetric, transitive, satisfied. All the conditions are satisfied in this relation, in R. Hence, this R is an equivalence relation. I think you have understood my point. These three conditions are satisfied, hence R is an equivalence relation. Equivalence relation. This relation is very important. I am going to take you one more example. I am going to take one example of NCERT book. Very interesting example. Now see this example. Let T be the set of triangle. Let T be the set of triangles. Let T be the set of triangles in a plane. R be the relation in T. R be the relation in T. R be the relation in T. Given by R is equal to condition. Condition is given. R is equal to T1, T2, such that T1 is congruent to T2. T1 is congruent. The sign of congruent, I'm not going to write congruent word. I am writing sign. T1 is congruent to T2. So that R is an equivalence. So that R is an equivalence relation. My dear students, this is a good example. This is a good question of your NCERT book. Now we have to prove that this relation, we have to prove this relation is equivalence relation. And for equivalence relation, we have to prove three relation: reflexive, symmetric, and transitive. Now listen to me. First, reflexive. Reflexive. Reflexive, in reflexive condition is if T belongs to R. If TT belongs to R, it means triangle, one triangle. This is the same triangle, and a condition is this: both the triangles should be congruent. But these are the two triangles in a reflexive. You have already read that in reflexive both the elements are same. If both the elements are same, the triangles are the same. And condition is that both the triangles should be congruent. Every triangle is congruent to itself also. Every triangle is congruent to itself also, because the triangles are same. So there is no difficulty in proving both the triangles are congruent. The first triangle, this is the second triangle, both the triangles are congruent. So this condition uh, here, this condition is proved. Now second, symmetric. If T1, T2 belongs to R, this implies T2, T1 belongs to R. I have told you that if T1, T2 belongs to R, opposite should also belong to R. Here you see that if first triangle is congruent to triangle second, then second triangle will be congruent to first. There is no question of uh, thinking here. When this triangle is congruent to this congruent to this. So therefore T2 is also congruent to, because both are same. This congruent to this congruent to this. Hence this condition is proved. This relation is symmetric also. Third, transitive. If T1, T2 belongs to R and T2, T3 belongs to R. This implies T1, T3 also belong to R. See here, T1, first triangle is congruent to second, given. Second triangle is congruent to third triangle, given. Two, because in transitive relation, two conditions are given. This is given, this is given. We have to check in that relation. This is also should be there. Now T1, T3. If T1 is congruent to T2, this congruent to this, and this congruent to here, T1 is congruent to T2, and T2 is congruent to T3. From first, T1 is congruent to T2. From second, T2 is congruent to T3. This implies that triangle T1 is congruent to T3. Hence, this condition is also satisfied. This is a third condition, and all the conditions in this question are satisfied. So this relation is an equivalence relation. We have proved all the three conditions in this relation. This is the equivalence relation. Now there are so many questions. So we will take more questions later on in third part. In third part, we will learn very important topic in third part. In third part, a relation, one relation, on to relation, this type of relation I am going to teach you in third part. Thank you.